Alright guys, welcome to your sound video tutorial. In this video we will be talking about harmonics. Now, with these types of questions you can have two different types of scenarios. Really, anytime you're talking about a stringed instrument, you're going to have a string or a rope that is fixed at both ends. So you would have something that looks kind of like this. And this produces this type of standing wave pattern. Oop, that got away from me. And your one question might be asked, well, what harmonic are you on? Well, to do that, it's very easy. All you do is count the antinodes, or the places where only constructive interference is taking place. So here I have 3 antinodes, so I am on the 3rd harmonic. There's always one more node than antinode when you're dealing with something that's fixed or open at both ends. So here I've got 1, 2, 3, 4 nodes. So I've got 3 antinodes, 3rd harmonic, and I've got 4 nodes. Another type of question would be, say you've got a pipe that is, let's say it's 1 meter long, and it vibrates at a frequency of, let's just say 20 hertz, the lowest 20 hertz, the lowest frequency that human beings can hear. Now when I say that, I mean that this is the fundamental frequency. In other words, at that frequency, N is going to be equal to 1. And so when that happens, you have this equation, because again, you're open at both ends, times V over 2L. Easy way to remember this, you've got 2 ends that are open, you've got 2L. So N times V over 2L. And I would give you the speed of sound. Let's say the speed of sound is 330 meters per second. And you plug in your fundamental frequency, which is 20. N is 1, so you don't really need to put that in. And you've got 330 over 2L. In this case, L is 1. And in this case, we haven't been given really any unknowns. I gave you how long the pipe was, I gave you the frequency, and I gave you the velocity. So a question would be, I give you the length, I give you the velocity, and I ask you to solve for the frequency or one of the others. So let's do a type of example with this. And let's say that I've got a length of pipe, and let's say its length is, let's go 2 meters. And the speed of sound is 330 meters per second. And I want to know what the fundamental frequency of this pipe is. So again, it's open at both ends. So my frequency is equal to N times V over 2L. I'm on the 1st harmonic, so F1 is 1 times 330 over 2 times my length is 2. So that becomes 330 over 4. And then you just divide that out. So 4 goes into 33 8 times. 1, so that would be 2. And 82.5 hertz would be my frequency. So a way that I could change this question up is I say, okay, well now this pipe has a flap on the end, and now the flap closes, and I want to know the frequency of the closed pipe. Well, here, now that you've got a closed pipe, your equation changes to N is V over 4L. Think a golf hole is only open on one end, and you yell 4 when you play golf. So there, you know the length, it's 2. Your fundamental frequency is going to be 1, and your speed is still 330. So this would be 4 times 2, or 330 divided by 8. And so that would be 41.25 hertz. So that's harmonics. Again, don't forget that velocity is distance over time. If I tell you how far the wave goes and how much time, you can calculate the velocity. And also don't forget, old reliable here, frequency times lambda. Very useful equations for your test.